Trigonometric identities. A trigonometric equation which is true for all values of unknown quantity. Number 1. Reciprocal identities. Reciprocal trigonometric identities involve the relation between the core 6 trigonometric functions: sine, cosine, tangent, secant, cosecant, and cotangent. These identities express each function by a formula that makes it equal to the one over another trigonometric function. The 6 identities are: sin data equals to 1 over cosecant data. Number 2, cosecant data equals to 1 over secant data. Number 3, tangent data equals to 1 over cotangent data. Cosecant data equals to 1 over sine data. Number 5, secant data equals to 1 over cos data. Number 6, cotangent data equals to 1 over tangent data.
Thus, the reciprocal identities can be simplified equations that involve multiple trigonometric functions into ones consisting of only one function type. For example, the expression cosecant data over sine data plus 1 over sine squared data can be converted into a much simpler formula. Since cosecant theta equals to 1 over sine theta, we can we can rewrite the expression as 1 over sine theta over sine theta plus 1 over sine squared theta, which can which can be further simplified to 1 over sine squared theta plus 1 over sine squared theta. This can in turn be further reduced to 2 over sine theta can in turn be further reduced to 2 over sine squared theta by the rules governing the addition of functions. We could have also alternatively used the cosecant theta equals to 1 over sine theta identity and obtain a result in terms of the cosecant, which could be 2 cosecant squared theta.
Quotient trigonometric identities. Quotient identities represents the relations in the ratios of core trigonometric functions, namely the sine and the cosine. They are alternatively labeled quotient trigonometric identities since the quotients of the sine and the cosine function is utilized to derive the functions for the tangent and the cotangent. The identities are: tangent data equals sin data over cos data. Number 2, cotangent equals to cos data over sin data.
Let's use these identities to once again simplify complex trigonometric expression into much more generable ones. For example, consider the daunting-looking cosecant squared theta over cotangent squared theta plus tangent squared theta over sine squared theta. We can use the ratio identities to break down the cotangent and the tangent terms into their sine and cosine components. And last, Pythagorean identities.
As their name suggests, were discovered by the Greek mathematician Pythagoras and also represents equations. The hold true regardless of the angle in equation. The three core identities are: sine squared data plus cosine squared data equals to 1. 1 plus tangent squared data equals to secant squared data. 1 plus cotangent squared data equals to cosecant data.
Utilizing the second and the third identities yield similar benefits. For example, we can utilize the second Pythagorean identity in combination with the reciprocal identity from the first section of this guide to simplify. Cosine squared theta, open parenthesis, 1 plus tangent squared theta, closing parenthesis, into cosine squared theta, secant squared theta, and further into cosine squared theta, 1 over cosine squared theta, which is equal to 1. Examples. Number 1. Cotangent theta secant theta equals to cosecant theta. Proof. Cosecant theta over sin theta times 1 over cosecant theta equals to cosecant theta. 1 over sin theta equals to cosecant theta, which cosecant theta equals to cosecant theta. Tangent theta over 1 over cotangent theta. Proof. Tangent theta equals to 1 over cosecant theta over sin theta. Tangent theta equals to 1 times sin theta over cosecant theta. Tangent theta equals to sin theta over cosecant theta, which tangent theta equals to tangent theta.